Hi everyone, my name is Michał, and as it was already said, I will talk about an XSS I found in application called Google Collaboratory, including a CSP bypass. So, I am a pen tester. I also write articles in a Polish blog called Sekurak. I have also an English language blog, blog bentkowski.info. You can find me on Twitter on twitter.com/securitymb. And I am also in the Google OXOA list, which is a list of 11 best bug hunters. Currently, I think I am on 6th place. I am not really sure. It changes quite frequently. So what are we going to talk about? I will start with the basics because, well, the presentation is about an XSS found in a bug bounty. So I just say a few words about what XSS is and what a bug bounty is. Then I will show you an exact case study of an XSS bug I found in Google Collaboratory. So you will see what I tried, how I failed in the beginning, and what I was able to do to exploit the XSS at last. And at the end, I will show you how I was required to bypass content security policy for that XSS to execute. So, okay, before we begin, I also have an unusual request. I have some problems with hearing, so there could be some problems when you want to ask questions, especially since English is not my native language. So whenever you have a question, please just go to the http bentkowski.info/q address, and you can write your question over there. At the end of the presentation, I will go to the page and I will see what questions are there and answer them. You can also vote for questions, so please go over there. The address will be shown on the screen the whole time, so you will not forget it. Okay. So let's start with the basic stuff. The presentation is about XSS, and I also have 3 books to give away, so I need to ask some questions for you so that I can give them away. So the first question is, what XSS stands for? Okay, I'm not sure who was the first one. Okay, let it be. So we will have a book. Of course, XSS is cross-site scripting. I guess most of you already heard about it. And XSS is a vulnerability that is most often associated with the infamous payload, either script alert 1 or image source equals to 1 on error alert 1. So this is actually sufficient to prove that an XSS vulnerability exists. However, it doesn't at all show what you can achieve with XSS. And okay, this might be another question for you. What are the main consequences of XSSs? Okay, over here. Okay, the first consequence is to get cookies. So it is usually used to steal session identifiers. Okay. Okay. Anything else? Excuse me? Okay, that's actually, I could say, the best answer, that you can do everything what you can do with JavaScript. And if you write your web applications, the front end of your web application in JavaScript, then you know that you can program just everything. And well, with XSS, you can perform any actions on behalf of the victim. So for example, in Gmail, you can, I don't know, send some emails. You can read anything the victim can see. So you can just get the inner HTML of the page, and you can just read everything. And traditionally, XSS was used to steal session identifiers. However, in modern age, we usually have HTTP-only cookies, so it couldn't be done. But it is still worth mentioning. Okay. Let's move on to one slide about bug bounty. If you don't know what bug bounty is, it can be described in a very simple way. It is just a program that, for example, Google has, that you can submit security issues, and you will get paid for that issues if they are valid issues, of course. So for example, Google pays at least $3,000 for any single instance of XSS in any google.com domain or subdomain. Okay, so let's move on to the main thing. Now I will show you the XSS I found in the application called Google Collaboratory. Have you heard about the application, the Google Collaboratory? I am not really surprised because I don't think it is very well known. And did you hear about the other application called Jupyter Notebook, perhaps? It is probably more known. In Google Collaboratory is based on Jupyter Notebook. It is used in some people that perform some research, because here you can write some markdown over here. And also, you can have some Python code. And the Python code is executed directly in the collaboratory. So for example, you can use it to gather some data and then write a Python script that plots the data. And here we have some graph. Or even, for example, you can plot Venn diagrams. So what I was interested in here in the first place was the Python code. I can execute a Python code and it gets executed immediately. So it looks pretty interesting. So I use the typical Python function called dir, which shows me what objects are can be seen in the current scope. So I execute the dir. It takes a little while. And then we will see that the code was actually executed. If you are familiar with Python and its toolset, then you can recognize that the code wasn't executed in a plain Python, but in IPython. It is another interpreter of Python. And in IPython, you can call any shell commands when you prepend it with an exclamation mark. So I try exclamation mark, ls, a, and as you can see, the ls was executed. At this point, I was wondering, what kind of user privileges do I have? Let's find out. Let's try to execute ID. And wow, that's pretty good. I mean, I just started my work and I already finish, so it's great. Of course, the reality isn't as bright because you might remember that the first execution of the command took us slightly longer than the subsequent ones. And it was because actually when I tried to execute the first command, Google created a virtual machine in Google Cloud for me, and everything I do is executed in the Google Cloud virtual machine. So it's not really profitable for me that I have a root account because, well, you can create your own virtual machine in Google Cloud and it doesn't give you access to other people's data. Okay, so let's try something else. Let's go back to the stuff I usually focus on, and XSSs. Here we have Markdown. I guess most of you are familiar with Markdown. You can use the hash sign to put some headers. You can put some italic text on some bold text. Also, what is quite interesting, in most Markdown parsers, you can use HTML tags as is. So I have the strong tag, and when I have a look at the DOM tree, you can see that the strong tag is over here as well. So my first idea, would it be that easy? I mean, could it work? A very simple XSS payload. As you can see, the image is over here. However, no alert is shown. So let's have a look at the DOM tree. And in the DOM tree, we can see that the image tag is there. I maybe try to zoom it a little bit. Okay, the image tag is over there. However, the on-error event handler is removed. I will go back to that later, what exactly removed the on-error error handler. So let's try something else. That is one attack vector that works in Markdown parsers very often. You can use links using the syntax with square brackets and then the oval bracket. So as you can see, here's a link to SecurePL. And there is a very fine protocol that browsers support, and the protocol is called JavaScript. So I tried using the JavaScript protocol. However, as you can see, it didn't work. The link is not blue. It wasn't changed to a hyperlink. So it somehow is able to recognize whether I am using the normal link or whether I am trying to use some JavaScript protocol. However, I noticed that when I use the HTTPS link and then some random characters that are not valid in URLs, the URL is still created. So I thought that perhaps there is some kind of a very simple regular expression that is used to check whether the URL is correct. So I tried to find it in the sources. So I have a look at the sources, to the wrong file at first in the movie, then in the right one. And I tried to find the regular expression. And I guessed that there will be a string HTTPS and question mark. And I actually found the regular expression. Long story short, I wasn't able to bypass the regular expression. However, I had a look at the code that was near the regular expression because I knew that in this code, they are trying to sanitize the HTML. So maybe I will find something interesting. And I was browsing it, and browsing it. And then I noticed something that caught my eye. And you can see it over here. It was goog.html-sanitizer.savedom3 processor. So what is it? Let's try to Google it. And when I Googled it, I found out that it was actually a sanitizer used by Google's Closure library. To keep things simple, the Closure library, which is maintained by Google, has a sanitizer. And the sanitizer uses both whitelist and a blacklist of tags. Here you can see the blacklist of tags. So here are the tags that you cannot use in the HTML at all. But also, you have a whitelist of tags. So here are the list of tags that you can use in your HTML that will not be removed. I was trying to bypass the sanitizer from Closure. However, I wasn't able to. I mean, this is a very popular solution, so it wasn't very likely that it would be easy to bypass it. So I went back to the collaboratory and have a look at the pentester's best friend, which is a documentation. So let's have a look at the Markdown guide. First of all, the documentation lies, as you'll be able to see, because it says that the collaboratory does not allow HTML tags in the Markdown, unlike most other Markdowns. I have shown you that it is not true. However, what caught my eye over here is that collaboratory accept LaTeX by using the JavaScript library called Matjax. I missed that somehow before, so well, I thought that I might have a closer look at it. So let's try with something simple. I mean, I have a fraction 1/2, and let's see how it looks in the DOM tree. And at first, you cannot see anything particularly interesting over here. I just have some spans. However, there are two things that caught my eye. The first one is a span with class MJX assistive matml. It is very interesting because over here, we can see mat tag, mfrag tag, and mn tag. And those tags weren't in the whitelist I showed you before. So why are they over here? They should be cut, but they are not. And also, slightly above, you can see HTML attribute called data matml, which contains an HTML with the exact the same content that I've shown you before. So, let's see that if I am really able to use the mat tag or if I am able to use the mfrag tag. So now I will have a look at the DOM tree. And in the DOM tree, there are no mat tags, there are no mfrag tag. So the conclusion over here was that medjax somehow omitted the closure sanitizer. So now I didn't have to find a security issue in sanitizer. Now I had to find a security issue in medjax. So it seemed to me that would be much more possible because, well, Google Sanitizer is very well known, and I guess that nobody ever had a look at the security of medjax. So let's see that. Let's look at the documentation. And in the documentation, we can find out what LaTeX macros are supported by medjax. And there was a macro that I found interesting, and it was called href. I mean, okay, maybe it didn't work before, but it would work now. So let's try it. So I put some LaTeX code over here. I use the href, first with Securak to find out whether it works at all. And as you can see, it does because there's a hand. And then, well, maybe JavaScript. But tough luck, it didn't work. It turns out that medjax has a so-called safe mode, and you can just disable the JavaScript protocol. So no luck over here. But I just went back to the documentation, and I just tried any non-standard LaTeX macro. And then I noticed a macro called Unicode. It is a very simple macro. You can just use the Unicode code point of a character, either in decimal or in hexadecimal. So let's have a look how it works. I use the Unicode of 65 and then Unicode x41. 65 decimal, x41 hexadecimal, uppercase letter A in both cases. And in the DOM tree, there is a very interesting stuff because we can see the HTML in the data.matml attribute. And as you can see, when I wrote 65, then there's 65 in the HTML. When I wrote x41, then there's x41 in HTML. So it is not transport in any way. So what might happen if I try to use some HTML in here? Would it be encoded or not? And as you can see, it is not encoded at all. And slightly below, we will see that it will render in the DOM tree. Okay, so let's do it. Let's try with the very simple XSS payload, image on error equals to alert 1, and nothing happens, no alert over here. Let's have a look at the DOM tree, and the element is in the DOM tree, so the on error is not cut over here, so it should work. And I was confused for a while. I wasn't sure what's going on over here until I had a look at the JavaScript console. And here we can see an error from content security policy. Who knows what content security policy is? Not many. Okay, well, as you can guess, it is a security mechanism in the browsers that is supposed to block XSS attacks. And it worked, as you can see. However, at this point, I thought that, okay, I just have to make sure that it is CSP that blocks the attack. And I had a browser extension called CSP disable. And as you can see, I was able to confirm that it was actually content security policy that blocked my payload. So I thought that I should report the bug to Google anyway, because there is a content security policy that blocks the attack, but it doesn't change the fact that the XSS is over here. So I reported the bug. As you can see, it is 2 minutes after midnight. And I reported that there's an XSS in Google Collaboratory. It doesn't work because of CSP. However, you can confirm that it exists. And at this point, I thought to myself that, well, I need to go to bed. And then when I wake up in the morning, I will try to bypass the content security policy. However, when I try to go to sleep, it looks something like that. I couldn't sleep. I couldn't stop thinking about that. I just thought that, okay, I need to do something. I need to somehow bypass the content security policy because, well, it is not cool to report a bug that doesn't actually execute. So I need to just get up and focus on that stuff. So let's have a look how the content security policy in Google Collaboratory looked like. And there are actually two keywords that are important. The first one is nonce, and the second one is strict dynamic. I will show you a rough idea how it works. So first of all, when I have a content security policy with a policy using the word nonce, I need to create some kind of token that should be regenerated after every refresh of the page. As you can see, the alert didn't execute right now. However, when I add the nonce attribute to the script tag with exact the same value that was in the content security policy, then it would execute. The idea is that the token is regenerated after every refresh, so I am not able to predict what value it's going to have. So this is nonce, and strict dynamic allows us to do something that is very often seen in the analytics scripts. So you have a script that adds another script to the DOM tree. And when you have a strict dynamic, you trust scripts that are added by already trusted script. So this is something like a transitive trust. So this script from the some other domain will be trusted because the script that adds it is trusted before. Okay, and that was a very interesting presentation called Breaking XSS Mitigations via Script Gadgets by Sebastian Lekes, Krzysztof Kotowicz, and Eduardo Vallanava. And in this presentation, we could see a table which shows what kind of content security policy you are able to bypass with what popular JavaScript framework. You might have noticed that Google Collaboratory used Polymer. And as you can see, you can bypass just any content security policy when you have Polymer. So let's have a look how Polymer works. Polymer makes it possible to use something that is known as web components. So you can define yourself a component. For example, here we have a component called contact card. And we have some script. We define the behavior of the element. And then later in the HTML, we can just use an HTML element called contact card. And it would work just as we wrote it. So my idea was that I will have a look at the original Polymer elements that are used by Google Collaboratory. And there was an element called collab dialog imp. It was used when there was a modal dialog window after clicking on some buttons. So I will go back to the XSS. And I will try to overwrite the original collab dialog implementation. I will just add some random text over here. There is a typo, but it doesn't change anything. And we will see that when we press the share button, then we will not see the original share button window, but we will see just the some random text. Let's have a look. I need to refresh the page, then press the share button, And as you can see, there is some random text. So I was actually able to bypass the original element of collab dialog imp. So then I will change my code, and there will not be any some random text, but then I will just put a script tag over here. If you remember the strict dynamic content security policy, the script tag that you see over here will be actually added to the DOM tree by Polymer. Polymer is already trusted, so this script would also be trusted. I also added here the collab dialog imp element by myself, so that the XSS executes without any user interaction whatsoever. So I will just refresh the page. Then I don't have to do anything, and as you can see, here's an alert. So we have a content security policy with a seemingly very strong policy, and we were able to bypass it using the so-called script gadgets. So I wrote to Google that the CSP can be circumvented pretty easily at 3:28 a.m. And I used a slightly different payload. I guess that it was because of the time. I wasn't able to think straightly that you can do that in a more simple way. But, well, it still worked. And then I was given a bounty of $3,000. So to summarize, I had an XSS in Google Collaboratory application thanks to XSS in MadJax library. The MadJax library was fixed, so if you use MadJax in any of your application, then please upgrade it. The author didn't actually say over here that it fixed the XSS issue. It just fixed parsing and output for class and Unicode. However, it just fixed the XSS issue. I was able to confirm that some other website in the internet that used MadJax was vulnerable to the XSS in the same way that Google. So please update MadJax if you use it. Okay, that's it. I will have a look whether there are any questions. Okay. How much wood would the woodchuck chuck if the woodchuck could chuck wood? I guess I can't answer that. Okay, could you please check the CSP header in the Google CSP validator? I can do that. I guess you meant the CSP evaluator. And the application was Collab Research Google.com. But as far as I remember, the evaluator would say that the policy is great. Let's have a look. So I will copy the policy. The CSP evaluator is a simple application in which you can paste some content security policy, and it will tell you whether it is safe. As you can see, okay, it is unsafe eval, but generally it is good. But it is not good if we have some kind of JavaScript library that makes it possible to bypass it. Okay, what did you use to create your presentation? I used a software called ScreenFlow. Okay, ScreenFlow. So I just recorded a video and then do some fancy stuff, and then it looked like that. Have you been talking with the guys from Google that had the presentation on CSP today? I haven't, but if they are still over there, I would love to. Okay, so that's it. Thanks for participation. If you have any question, you can go over there and ask me.